All right, guys, step one of cellular respiration, glycolysis. We're going to be starting off respiration, breaking down the glucose that we began with into something called pyruvate. Just another molecule. Now, guys, this step is actually going to be taking place in the cytosol. Okay, we're actually not in the mitochondria yet. That will come in later steps. Now, we're going to be able to get about 25%, a little less, of the energy that's stored in glucose out. The rest of it, though, is going to be stored in that pyruvate. So we're only getting a little bit of the energy out at this point. Let's walk through this diagram and take a look. So we start off with glucose. Glucose would be our reactant. And again, we end up with pyruvate molecules. That would be our product. Keep in mind, glucose formula H12O6. What we're actually going to be doing is taking our glucose and essentially snapping it in half. So glucose has 6 carbons. Let's kind of sketch that out. Now, we're not obviously showing the oxygens and hydrogens, but it's a 6-carbon molecule. And what we're going to do, snap that in half. It's a little more complicated than that when it actually happens, but it'll give you the basic idea. And we're going to end up with 2 molecules that have 3 carbons each, and that's our pyruvate. And in doing that, we're breaking it down, and we're going to be getting some energy out. So keep in mind, this is a catabolic or exergonic reaction. We start with high energy product or reactants, and then we end up with a lower energy state product. What do we get out of it? Some ATP by the end. Now let's go into a little bit more of the details about how that actually happens. Notice the shape that you see here. We start again with a high energy reactant, and we end with lower energy products. Catabolic reaction. We start with 1 molecule of glucose and end up with 2 molecules of pyruvate. Now keep in mind, in a catabolic reaction, there is a hump that we have to get over. That's our activation energy barrier. We've got to put a little energy in order to get over that hump and start the process. So here's the energy we're going to put in. 2 ATP get dumped into here, which means we end up with 2 ADP that can be recycled for later. So we're going to put some energy in. The next thing that we're going to do is we are going to pull 2 electrons out of the glucose and give them to what's called NAD+. That will turn it into NADH. Now, what you need to understand here is NADH is just a temporary energy storage molecule. So we're pulling, in the form of electrons, a little bit of energy out of glucose, and we're giving it to this NAD+, which turns it into NADH. It's temporary. We're going to use that later. So we will be coming back to it. Our goal, though, is to stockpile as much of this as we can. Now, some of you might be wondering, I don't get it. Why do the electrons plus the NAD plus turn into NADH? Well, consider this. H represents hydrogen. What does it take to make a hydrogen atom? You need 1 proton plus, 1 electron. You've already got a proton here, and then we're going to give electrons there, and do that with 2 of them. So 1 proton plus 1 electron, and that will help us to get our hydrogen atom onto the end. Now, ladies and gentlemen, this here is going to be a redox reaction. And let's recap. Redox reactions, how do you remember what's going on? Leo says Ger. If we're losing electrons, we're being oxidized. If we're gaining electrons, we're being reduced. So ladies and gentlemen, right here, who is losing these electrons? Who are we taking these electrons from? glucose. So glucose is going to be the one that is being oxidized. It's losing. But anytime we've got a redox reaction, when something is being oxidized, something else has to be reduced. So who's gaining those electrons? NAD+. So quick recap. We begin with our glucose. We dump in some energy to get over the activation barrier. And then as we go through a series of changes, the details of which you don't need to know right now, you'll learn some of them in AP, we take out a few electrons from our glucose. It's losing, which means it's being oxidized. We give them to a molecule called NAD+, which means it's reduced because it's gaining, and that turns them into NADH. This is something that we stockpile for a later day, temporary energy storage. Now, at the very end of this process, we're able to get a little bit of energy out of the glucose. And we do this by taking 4-ADP that are just floating around and turning them into 4-ATP. By the end of the entire process, we get our 2 C3 molecules of pyruvate. So pay attention to this box up here. It's going to be pretty important. For every molecule of glucose that we send through this process, we will end up with 2 ATP, 2 NADH, and 2 pyruvate. Now, some of you might be looking at this and saying, I don't understand. We have 4 ATP right here. You're right. But to get this process started, we had to put in 2 up here. Net result, we get 2 ATP out of the process. And that's step 1.